So today we are going to continue talking about section 5-6, working with simplifying radicals and square roots. However, now we're going to approach the solving part. So if you remember from the very beginning of the chapter, the first thing we started with in this chapter was graphing. And we graphed the x squared equation, and we said that graph was a parabola. So way back in the beginning, we looked at y equals x squared, and the graph of it, called a parabola, which remember made that U shape. It either went up or it went down. That was the shape of this graph. And then after we did the graphing, we've been focusing on factoring. And the reason we factor is to break a problem down into multiplication. And then the end goal was for us to solve for x, because that's really algebra. Algebra is solving for x in many different types of equations. So we're going to continue to solve for x, but we're not factoring anymore, because factoring is one way that you can solve for x, but it's not the only way. So today, we're going to learn about a method for solving equations by using square roots, which is what we've been working with. So the reason we were kind of working on square roots and simplifying square roots was so that we could eventually solve an equation by finding square roots. So the first thing we have here, it has solving a quadratic equation. And we're not actually going to write a definition here. Instead, we're going to write a couple of steps. So solving equations is something that we did at the beginning of the year, and the goal for solving an equation is to solve for x, or to get the variable by itself. So the first step of solving a quadratic equation is to isolate x squared. Remember, isolate means get the variable by itself. So instead of just having an x, a quadratic equation has an x squared. That's what makes it quadratic. So we no longer will just have x, but now we have the x squared. So we're still going to talk about solving for x in the same way that we would have solved before. So we're now solving for x squared, isolating it, getting it by itself. The second step, we are going to be getting x by itself by taking square roots. So step 2 is going to be take the square root of both sides of the equation. And remember, the reason we have to do both sides is because an equation needs to be equivalent. So whatever you do to one side, you have to do to the other. The last part is a little weird. After we take the square root, our answer is going to be plus or minus some kind of number. So our answer is going to be x equals plus, and this is this little symbol here. It's a plus or a minus, a positive or a negative answer. And it's going to be some number, and I'm going to call it A. That's a new part that we're going to look at as well. So our answer is going to have a plus and a minus in it every single time. And the reason that is, there's actually two reasons. The first reason is because we have a parabola, and a parabola has a positive side and a negative side. So if you think that there's really a graph sitting here, every graph has a plus side and a minus side. It has the positive x values and the negative x values. So that's why we have this plus or minus for every answer, because remember, parabolas are symmetrical. They have symmetry. So we have that same answer on the left and the right. The other reason it's plus or minus is if I think about the number 9. 9 is 3 times 3. So we would say 3 squared equals 9. But 9 is also negative 3 times negative 3. So we could also say negative 3 squared is equal to 9. And that's how I get plus or minus 3. So because I have that plus or minus option, so 9 is really 3 squared or negative 3 squared. So plus or minus. So all of our answers, again, are going to have that plus or minus option. So there's really two answers. And again, two ways to think about it. Every number can be a positive times a positive or a negative times a negative to still get a positive answer. Or looking at the parabola has a positive side on the x-axis and a negative side on the x-axis. So we're going to solve the first three problems here, and we're going to see if we can just follow the directions to solve this quadratic equation. So the first step says to isolate x squared. So if I look at A, we have x squared plus 1 equals 13. Isolate means get it by itself. And right now, there's a plus 1 in the problem. So we need to take that plus 1 to the other side by doing the opposite. So if it's a plus 1, the opposite is to subtract 1. And then when you subtract, the 1 plus 1 goes away. That's our goal, to get that to cancel. 13 minus 1 is 12. So that would be isolating x squared. The second step, it says to take the square root of both sides of the equation. So we have x squared, but our goal is to solve for x. So if we take the square root of both sides of the equation, that is another way of getting something to cancel. And that's how we get our power to cancel. So the square root and the squared, the x squared part, they cancel and they just equal x. So now I have the square root of 12, and we have to think about what we've been doing last week, and we have to break down the square root of 12. So we have the square root of 12, and we need a perfect square to go into 12. So we're not having decimal answers. We're not plugging this in the calculator and taking the square root of 12 and getting a decimal. Instead, we're thinking about a perfect square that divides into 12, and that would be 4 and 3. So 4 times 3 makes 12. The square root of 4 is the perfect square, and it becomes 2. And then we have the square root of 3. So here we took the square root of both sides of the equation so that we just have an x, and then we had to simplify the square root of 12. I'm on step 3 now. It says the answer is plus or minus a, plus or minus any number. So I need to put a plus and a minus sign in front of that number. And the reason we do that is because both the positive and the negative work. So if I took 2 times the square root of 3 and 2 times the square root of 3, I would get 12. Or if I did negative 2 times the square root of 3 and negative 2 times the square root of 3, I still get a 12. So your answer is going to look a little weird. But this here is our solution. So it's not a nice pretty number of just a 3 or a negative 7 or a plus 5. And it's not a decimal and it's not a fraction, but instead it's a number with a square root. So we're going to use this process again for B and C. So looking at B, we would subtract 2. So we're isolating x squared. That's step 1. And we would write x squared equals 2 minus 2 cancels. 36 minus 2 is 34. Okay, so step 1, isolate x squared. Step 2, take the square root of both sides. So that's the second step. The reason we do that is because the square and the square root cancel, leaving us with x. Remember, our goal is to get things to cancel to leave us with x. And then we have to look at the square root of 34 and think about any numbers that divide into 34. Well, 1 times 34, 2 times 17, and then nothing else goes into 34. And if I use a 2 and a 17, I cannot take the square root of 2. It's not a perfect square. I cannot take the square root of 17 because it's also not a perfect square. That means I can't do anything else with this problem to get it to simplify. Sometimes numbers don't simplify. So instead, my answer, the last part, put a plus or minus in front of it, and then the square root of 34. So sometimes the answer can't be broken down and it just stays as a plus or minus and then a square root of 34. So remember, we're trying to solve for x by using square roots. So number 3, or letter C, I'm sorry, doing the same thing, isolating x squared, we're going to subtract 3. So 3 minus 3 goes away. 21 minus 3 is 18. Second step, now we have to take the square root of both sides of the equation to keep it equivalent. My square and square root cancel, leaving us with x. And now I have to think about the square root of 18. Can we break down the square root of 18? Well, we actually can. 6 times 3 makes 18, but 6 and 3 are not perfect squares. 9 times 2 also makes 18, and 9 is a perfect square. So the square root of 9 becomes 3, and then we keep the square root of 2. The last step is to put that plus or minus in front. So x equals plus or minus 3 times the square root of 2. So every single one of those problems have a plus or a minus with it. So each of those problems were very similar, where we had to get x squared by itself by taking that number to the other side. So we took the number to the other side. In extra example 1, we're going to do, again, similar steps. Our goal is to solve for the x squared, so we're still going to follow that process, but these look a little different. So looking at letter A in extra example 1, again, solve the equation. We have to isolate x squared first. So we need to get x squared by itself. Well, in this case, we have 4 times x squared. And the opposite of multiplication is division. So we are going to divide by 4. So see if you can do that. Take the 4x squared and divide the 4 out. So now we have the 4's canceling. We have x squared. And then we actually have to take 108 and divide it by 4. Might need a calculator for that one. 108 divided by 4. I know 100 divided by 4, sorry, screen's flipping there. 100 divided by 4 is 25, so it has to be bigger than that. Let's see, 108 divided by 4, I think that's 27. So the next step, we got rid of the 4's. Now we have to take the square root of both sides. And then I have to think about the square root of 27. Can we break down the square root of 27? Well, yeah. The square root of 27 has a perfect square. Think about the perfect square. 9 times 3 makes the square root of 27. The square root of 9 becomes 3, and then we keep the square root of 3. The last part of my answer is to place that plus or minus sign in front. I have now 2 answers to every problem because that parabola has 2 sides to it. It has symmetry. All right, looking at letter B. Letter B looks a little different. Definitely a couple of steps in here. So when we have to solve an equation that has a 3x squared minus 5 equals 55, think about the first step that you would do here. Our goal is to combine the like terms. So the first thing that we would do, how would we try and get x squared by itself? Well, we would add 5. All right, so we added 5, and we have now the 5's cancel. 55 plus 5 is 60. The second step, again, trying to get the x squared by itself, would be to divide by the number in front. So this is a 2-step equation here to get x squared by itself. The 3's cancel. 60 divided by 3 is 20. And if it just said x, I would be done with the problem, but it says x squared. So I have to continue with step 2. We isolated x squared. Step 2 is to now take the square root of both sides. And now that we've taken the square root of both sides, we have to think about two numbers that multiply to be 20. One of them is a perfect square, and that would be 4 and 5. The square root of 4 becomes 2. We keep the square root of 5. The last step is to place a plus or a minus in front of the answer. So again, 3 steps there. Isolate x squared, take the square root of both sides, place the plus or minus in front of the answer. So we have one final problem here, letter C, that we're going to do together. Letter C, it looks like letter B, so it looks like a multi-step problem. And asking yourself the same question, how do we get x squared by itself? What do you do first? So negative 2x squared plus 13 equals negative 43. So think, how could you combine like terms? What's that first step? Well, we would want to subtract 13. And when I subtract 13, we have a negative 43 and a negative 13. They're both negative. That gives us negative 56. 13's cancel. Second step, we're going to divide by negative 2. So now I have to do negative 56 divided by negative 2. Use that calculator. So negative 56 divided by negative 2. That's going to make 28. And now the last step, we got x squared by itself. I'm sorry, not the last step. Step 2 is to take the square root of both sides. So taking the square root, we're on step 2, trying to get x by itself. So remember, our square root and our square cancel. And now I have to ask myself, what divides into 28? That's a perfect square. So think about the perfect squares. 4 times 7 make 28. The square root of 4 is a perfect square, and it becomes 2. Square root of 7 stays. The last step is to put a plus or minus sign in front of the answer. So x equals plus or minus 7. So you got to see 6 different examples. The first 3 involved a single step. Actually, the first 4 involved a single step. And then the last 2 that we just completed here, those require a couple extra steps to get the x squared by itself. So that is the lesson for today. Tomorrow there will be a short video working through a couple of problems from the homework worksheet that is practicing these types of problems. So you're going to look at different types of problems and try and isolate the x squared and then solve using square roots. Have a good day.